Okay, so again, if you have questions, feel free to type in the chat. Feel free to ask it either private question or public to everyone is fine. Actually, I kind of, to be honest, I do encourage a public question so that your friends can see the actual questions. But if you're shy or you like don't really want to like expose yourself to like, hey, I'm asking that thing. Yeah, that's fine. Let's ask a private question, whatever make you learn better, right? So today we'll actually now resume and dive into the environment of Linux or playing with Linux. And before we begin, recap of Tuesday. Not really sure why I say Monday here. So a recap from Tuesday, we cover what is a computer, right? Which is something like this. You have a processor, it takes input, somehow you write a program that processes the input, generate the output that the user can see. In the middle, there's a main memory that acts like a scratch pad. The purpose of memory is literally a lot of times you can think of it as a scratch pad that you use in real life, right? If you need to calculate complex math equation, you do that on a scratch pad before you write the output. That's the same purpose over here. It can interface with the input devices, your keyboard, the network interface, network card, like whenever you want to download something that goes through the network card as an input going to your main memory, get processed by the processor, then get output to either your hard drive or the screen, right? Or both. Conceptually, the operating system is basically it's a piece of software, right? Everything in here except for that little circle in the innermost figure part here that I label hardware. Everything else is software. Oh, I guess except the user, which is human, right? Uh, the OS circle around the hardware. Basically, you can think of it this way: it protects you from having to deal with the hardware. You get control over the hardware through the OS. You can interface with the OS. You can interface with the application, which get run inside the OS, right? You run Chrome in Windows, in Linux, in Mac OS, right? These things are run under the operating system. So conceptually, the OS is a piece of software that do something. What is that something? It interfaces with the user, control the hardware. For example, when you install driver, right? The driver, as the name suggests, drive the hardware. So it's a part of the OS. You install those device driver that allows you to control the devices from the user point of view. It allows the application to control different devices, right? Unix, we covered this a little bit more on Tuesday, is multi-user, multitasking operating systems, which have different versions. Linux is one of the popular ones and is typically used in many settings. That I would say is more like work-related setting. Anything that are serious here, cloud infrastructure, scientific application, IoT devices, PC workstation, anything that doesn't really requires nice GUI, right? But even then, if you look at Apple products, right, the Mac OS, which is also Unix based, right? These are really nice. They also have a really nice interface. If you look at Ubuntu these days, they also have a really nice interface, easy to use, user friendly, right? So if you think about it this way, basically Unix, the difference between Unix and say other type of operating systems is it allows multiple users to use it. But if you look at Windows, it also allows multiple users to log in at the same time as well. You can run multitasking. Windows also enable that. So this is basically what you would like from a typical operating system, right? Allow multiple tasks to run at the same time. Otherwise, your computer becomes pretty useless. You can run only one thing at a time. Right? So you would like to be able to enable multitasking. You would like to be able to enable the fact that many users can use a computer, right? Then we talk about the terminal, which basically allows you to interface with your computer. This is more like a connection between human and the computer, right? So this is basically it translates your keyboard input, the display from the host or the server side to the client side, which is basically your own keyboard or your own display. Then we talk about the program versus processes. What is a program? I asked a question that I'm not even sure I need to define it. A program is a program. When you write something, it's a program, right? It's a sequence of binary data that contains a machine instruction. This is kind of a dictionary explanation of a program. Example, Google Chrome, Dota 2, right? Games that you play, even Linux, these are programs, right? A program generate when you launch a program, when you actually run a program, they generate this thing called process. It's an actual instance of that program that are running that can have a starting point and the end point. Whenever you close the program, that is actually not closing the program. You terminate the process that program instantiated, right? And then we talk about shell, a program that takes your command and feed it to the OS. As simple as that. So basically, your interface from the user, you have the shell that kind of connects the user to the OS so that they can send it to the hardware or the application. Right? That's what the shell is. This allows you to control the OS directly from human perspective, basically. And locally, how shell and terminal work together is something like this. You have a shell that talks to the OS, you have the terminal that talks to shell, and then you have the user or you as a human being talk to the terminal. Right? So this is on your own machine. You might be asking, well, what about the case when I have a server, which you all will have access to this weekend, right? Remotely, the server, the SysQ server would look like this, right? You have host OS running Ubuntu. They have the shell, right? You can actually launch multiple instances of shell. You can be multiple shell processes. Each shell processes connects to the terminal on your own machine, which you control. And there's an interface between the two, allowing you to control the server, right? You can run application on the server side. You can write new program on the server side, right? You can compile a program on the server side. If you have the root privilege, you can install new things. You can actually break the server. That's why you don't really want to give root permission to a lot of people, right? They can come in and break your machine. So now that's what we cover on Tuesday. I was supposed to say Monday again for some reason. This week has been hectic for me. More on Linux. So we're gonna continue on to our second lecture, right? So now we're done with the recap. Wake up, everyone. So we move on to second lecture. So the first thing we need to talk about is every single thing on your computer is stored in a file, right? If you think about it, if you open your computer, regardless of Windows, Mac OS, Linux, everything is a file structure. You install something that becomes an executable file. What is an executable file? Can someone tell me what's executable file?
Generally an application that you can run.
Yeah, basically an application that you can run, right? Execute and run. Roughly, both of those words means the same thing. You're running something, right? That's why we call it executable files. You don't, well, I guess you do go to the files and run it. Programs are stored in files. There's also data files, right? For example, if you install a new game, for example, if I say install Far Cry 5, right? You will have a lot of texture and images, right? That is designed for the environment of that game, right? Far Cry is like a first-person shooting game, right? So I should be able to go in and kill things. Okay, that's a bad example, but yeah, basically I can see the environment. How do you do that? How do you actually generate the trees, the object, the other human being around that game, right? You would actually have files that contain the texture of the object. For example, the tree, it should have a texture that look like the tree. The leaf should be greenish, right? The bark of the tree should be kind of brownish, and you have a way to program such that basically the program would come in and then put everything together so that that thing looks like a tree. If you compare the tree in game from 10 years ago to 20 years ago to now, it looks so different. But the file structure looks roughly the same. It's just a matter of how you compress it. Right? Everything is a file. Everything in your computer is a file. Microsoft Word, when you save it, it's a file. That's the data files. The actual program is also a file. It's executable files. These things are organized into directory, or sometimes we call it folders, right? Same thing. Yeah. Not sure. Any questions here so far? Basically, you have files, you have directory. Every single operating system is organized this way. And in Linux, right, you can use the command ls, stand for list. Basically, it would list the files in that current folder. So we will go through actual example. Once we're done with the kind of like me throwing things to you, I'll actually open up, right, a connection to the server, the sysq server, and I type these command in so you can see the example. So over here, if you type in ls, it will list everything in that directory. So what directory are we in? You can take a quick look at this, right? You see it's in /var/log. We'll go into detail of like what slash mean, but basically think of it this way. If you use Windows, it's C:/something, right? If you use a computer and you use the what's it called? The browser, no, the Window Explorer, I'm not sure what it's called these days. Basically, the one that you can use to browse all the files. There'll be a path to the files, right? C drive, my documents, file name. It's the same thing here in Linux. The directory are organized in a tree-like structure. What does it mean, right? A tree-like structure. What is a tree? A tree has a root, and it branches out into leaf, right? This is called the root. This is called the, well, I guess the first subdirectory from the root. So this can be a thing like C:, right? The C drive. This is a subdirectory. So this can be C/my document, right? And this can be another subdirectory. That's why we call it it's a tree-like structure. You go from the root, you can go and browse every single file in your computer. If you are in the algorithm class or data structure class, you might realize this is a graph, right? If you take these days when you go to high school, do they cover graph a little bit? I'm not sure. It might not be, but I don't know. Basically, these everything here, every single file is connected, right? It means that you can access every single file from your computer, right? The extension .exe, .doc, right? .text, it doesn't really mean anything. So anyone want to take a guess on why do we care? Why do if we even have the extension? Okay, so let me address the question. This is a question, is the command the same for both Windows and Linux terminal? No, that's a great question. Windows start with MS-DOS, right? Is one of the operating system. Linux is using Unix operating systems. The command actually defined by whoever programmed that operating system, like the guy who invent Unix, basically. So the person who programmed MS-DOS and the person who programmed Unix, typically they're not the same person. So they use a different name for the command. For example, anyone heard about dir? What is dir?
It lists directories in Windows.
Yes, it
It's like
lists files in that directory, right? But this is for Windows command prompt, right? If you type in DAR in Linux, actually not sure what it would say. I think it actually would say there'll be some version that say like, "Do you mean ls?" So if you type DAR, it would literally say, "Do you mean ls?" Because it's the same command, it just uses a different name, right? And there's these thing called alias. What does alias mean in English?
Like another identity.
Another name you call by.
Yes, it's another name you call certain things by, right? So in Linux, you can create alias. For example, for your friends who never used Linux before but somehow use command prompt, which is weird, right? But you can say, I will make an alias for dir to be the same as ls. So when you type in dir, it would basically mean the same thing as ls. So anyone want to say a guess? So let's just come back to our slides. Anyone want to say a guess why I say file extension doesn't mean anything? In that case, why do we even have file extension .exe, .ps, .jpeg?
We know
to specify
what it is.
a program to run.
Yeah, exactly. To specify the type of that file, right? It doesn't mean anything to the operating system, but to the user, if I say node.txt, I would expect, right, that this is probably a text file that I can go in and read something from it. Something.jpg should be an image. I should be able to open it with a program that allows you to open an JPEG image file. .zip should be a compressed file, right? And yes, if you notice, a lot of viruses are .exe. Do you mind if I go into detail on that a little bit? We need to go sidetrack for like maybe 2 to 3 to 5 minutes. Okay, no one say anything. I assume that's a yes. So exe is executable, right? The way a lot of virus works, there'll be, I think in this lecture, I'm pretty sure it's this lecture, we'll talk about this thing called root privilege or superuser, right? When you become a superuser, you will become the god in that computer. You can do whatever you want. You can even format everything, delete all the files, right? You can change the driver to do weird things, right? And yeah, so that's another thing. So .exe, when you double click on it, right? From window points of view, .exe tells that is executable. So window will try to run it, right? When you try to run the .exe files, basically you run the program. Installer files or other .exe files. Sometimes when you run these things, it will have a ding and I say you want admin privilege, right? You've seen that before in Windows, right? In Mac OS, I actually forgot what they say because I never have enough money to buy the MacBook. Yeah, I'm joking. Actually, but if you use Windows before, you see that ding and say, I want to become an admin to run this program. What does it mean is, do you give that program the permission to become the god on that machine, right? What can virus do when it becomes the god in your computer? Anything. It has access to everything originally prohibited, right? It's protected by the OS. The OS, one of the jobs the OS has to do is to protect this important configurations files from the attacker. They typically virus would disguise itself as a .exe files, but sometimes they're not. There actually can be more advanced version of different viruses. They're gonna be .jpeg, right? They can be .pdf sometimes. They can be the Word documents. There are multiple ways to attack your computer so that because the key, right? The key here is you should, from the virus point of view, you do anything you want. Basically, you do anything in your power so that the user run the function you program them to run. That's it. It's a function that you write in a program, and you need to find a way to trick the user to run that function. Basically, that's the key of like creating a virus. That function typically requires things like root privilege. It would have that ding, say, hey, somehow I want to become an admin, right? And that's a really great point about, so please don't crack your games and movies because you might be actually downloading viruses disguised as these .exe files. A lot of time these viruses are pretty silent. Why they are silent? I mean, from the hacker point of view, what's your benefit of basically destroying someone's computer? Maybe try, but that's it, right? You don't get actual money. A lot of times when you have these viruses, they first become silent. You don't even know it's there in your computer. Then it would basically either change configurations, lock important services that you're supposed to be able to access, things like you cannot access the internet now, or let's say you are running a hospital. It's actually a real case, right? Where a big hospital all around the world get hacked. What they do is it's called ransomware. It acts like a ransom. Basically, it blocks the computer from accessing the patient database unless you pay the hacker. This is pretty evil, actually, because please, if you grow up, don't do this. Like, you actually playing with people's life. Like, people literally do die because of what you do. I'm not sure what is your what is those guys' thought process to be able to be that like bad. The key here is most of the virus will become silent, and then it will try to search your computer for the important things that they can take control of, right? Anyone heard about these like recent cases in the US that a lot of the government computer got hacked? So if you read news in this month, actually, there'll be a major security software company that is a contractor of a lot of government and big companies. What they do is they provide security services. It just happened that that software got hacked by Russian. Palantir is one of the companies that got hacked. So basically, this is big. This is really, really, really big in the security community because usually these are software companies that you have to trust to go into your computer to develop a security infrastructure for that computer. It just happened that somehow the Russian hacker get access to that and basically successfully attack that security company. It means that now everything that get the trust will be hacked or accessible by Russian, and they actually the not nice thing, but the crazy thing about this is it's been hacked for a while, and the Russian hacker basically becomes silent. They don't do anything, right? So no one knows that they got hacked until this month or until December. So it's been kind of pretty much widespread across a lot of government entity in the US plus companies, right? So yeah, I'm getting sidetracked. Anyway, that's kind of like the gist of like how virus works. A lot of time it's actually disguised as this legit files. Anyone heard about the checksum or MD5 check that when you download program from Android, they'll say, hey, we checked and verified the files, right? How it works is the legit program from the developers will be key, right? Basically, they will generate a key specific for this particular executable file, saying, hey, if I use the same method to generate the key, I should get the exact same MD5 sum, which is the key. What they do to make sure that the file you download from the App Store is legit is you check those keys from the developer saying, hey, this is my key. If you download the files and it just happened to have the same key, then the installer is legit. This is one way you can check for those possibility of having viruses. Okay, so file extension, come back to our class. File extension means nothing. You can use it to help the OS and the user. There are some executable files hidden as JPEG. In a few slides, we'll learn how to change the setting of the files so that you can run that file as if they are executable. So the computer would try to run it. Most of the time, it will not run because they will not know what is that instruction. It's some unknown, undefined instruction. So they complain like I cannot run this. Space in the file name is okay. I think this is common now. You can put space bar. I mean, it's called white space. Whenever you hit space bar, that means you insert a white space between the text, right? So you can have space in the files. To make sure that you can actually refer to that file, you need to add this thing called an escape character, which is the backslash. I'll show you in the when I'm actually demoing, right, how I play with Linux. Escape character means that whatever comes after this character is the literally that thing I'm typing in, right? It doesn't mean I'm sending the second files. It's just part of the same files. It's just the text. A part of that text is white space. Anything that starts with a dot, right, is a hidden file. So if you want something hidden, start with the dot. If you do ls, these files will not show up. If you do ls -a mean all, it will show up as a dot something. Then now we cover the file name and file structure. The next thing we need to cover is the path. What is the path? How do you go to the file, right? Think of it as every single file has its own address, like its home. Each file has its own unique address. You need the path to go to certain address to access the files. There can be an absolute path. What is an absolute path? You provide a full path. It's as if, say, I'm here in Nonthaburi, right? I would just say, okay, right now I'm at this address. I will provide the whole address. And then you should be able to come to my house right now and say, given the address, you should be able to come to my house. So that's the absolute path. The example is /var/log, right? /home/username, right? So this is in relation to the root directory. As I said earlier, if the file structure is tree-like, the root cover everything. From the root, there'll be a path to the file. You can provide a relative path as well. What is relative path? Let's say I want to go to 7-Eleven, which, by the way, limit yourself from going outside these days. It's kind of dangerous because of COVID. But let's say I want to go to 7-Eleven, and there's one about 3 blocks from here, right? I can tell you from here, walk outside, turn right, walk 1 block, turn left, and walk 2 more blocks, and you arrive at 7-Eleven. This is relative path. It's relative to where you are right now, right? So everything I specify here is relative to where you are right now. I'll go break this down. Dot, right? Dot mean current directory. So dot ASSN/01 means from the current directory, there should be a folder called ASSN or assignment. Then inside the assignment folder, there should be a folder called O1 or the first assignment. You can go there and read the assignment. If I say dot dot, go up 1 level. So dot dot means instead of the current directory, go back 1 level. So dot dot / leg/01 means I'm gonna go up 2 levels. Basically, you hit the back button twice. It's not exactly as a back button in Windows because back literally means the last place you visited, right? It means go up 1 directory, go up twice then go to a folder called leg/o1. There's also a spatial path, right? You just realize that dot means where you are right now, dot means going up one level. There are more. Spatial path tilde, this wiggle thing, right, refer to your home directory. In Windows, if you go to the home directory, basically you go to that folder that has things like my documents, my picture, my games, and whatever in that folder. In Linux, when I create a new user, it would generate a, let's say the username is say Rashada, right? My own name. So this is user. Then my home directory will be app/home/Rashada. It will automatically create this folder. And this is a folder wherever you start the terminal, you log in, it will be there. You'll be there. If for those of you who have Mac OS, right? If you have Mac OS and you open terminal, when you click on that button, this is where you'll be. This is why it's called the home directory. Basically, whenever you have the terminal, this is where you'll be. Dot means again the working directory, the current directory where you are. Dot means the parent directory, go up one level. Slash refer to the root, the topmost directory, right? It has access to everything. So I can do, actually, let me go to basic command because the first one is a change directory. But the basic way to send in command, right, through the terminal. Now you're gonna become the actor in the movie who are the programmer and they type in random things on a monitor and the command pop up, right? I'm gonna start to teach you how to put in those commands. So if you have Linux, you can type in the command this way. Start with the command name, obviously, because you need to tell the computer what you want them to do. Followed by the argument, right? What they want you to do and what's the object that ties with the command. For example, we covered ls like list. It lists files and directory in this current directory. For example, ls-l will list the directory where you are right now with additional details, right? Who owns that file? What group owns that file? What's the size of the files? What's the name of the file? What's the full path? You can also add in the argument about the location of the folder that you want to list. For example, if you do ls-l tilde means I want to go to the home directory, right? I refer to the home directory. So ls-l tilde means I'm gonna list the files and directory in my own home directory. What if I do this? ls/. It slash means I'm going to the root directory, right? So ls/ means that I'm gonna list whatever folder is in that root directory. It's kind of like dir::, right? You want to list whatever is in the C drive. cd change directory. That's why it's called cd. You basically call cd target. For example, cd/ go to root, cd tilde. Actually, I do slash this way. The ls should be going that way, direction of the slash. Cd tilde go home. Basically, go to your home directory. cd.hello, go to the folder called hello in this directory. Okay. cd stands for change directory. What else are the basic commands? If you want to create a new folder, you can call mkdir, make directory, basically make a new directory. Remove a directory, rmdir. One caveat before you remove the directory, this is for your own protection, because how many people accidentally remove a folder with files in it and you didn't intend to do that? Let me give you an example. One of my friend, lab mate, basically, he was like working on his simulator for his paper, right? And then he accidentally removed an entire folder from Linux. It was bad. Basically, all his work done for the past week are gone. So RMDIR, when you do this, it will first check if the folder is empty. If it's not empty, it will not do anything. It will only remove the directory if the directory is empty. This to save you from headache, right? MV move from source to destination. You move the file from source to the destination. You can use this command to rename the files as well. So let's say I want to rename a file called test to temp, right? What I can do is call mv test temp. These will basically move the file called test to a location, the current location, rename the files to temp, right? Source and new name, it will rename the files. CP, copy source destination. If you want to copy an entire folder, you can add -r. For example, CP-r assignment 1 slash, this is home, right? Your home directory, assignment 1. It will basically copy assignment 1 folder to your home directory. RM, so let me remove this example because it actually go over the text. RM stands for remove. No destination needed. My bad. It's not supposed to be there. Remove source, basically remove that file. You can add -r to remove recursively. Basically, whenever you have -r, it means recursively. Keep doing the remove for everything you specify. For example, if I have a folder called assignment 1, I do rm-r assignment 1, it will remove the entire folder. So be careful with that. Basically, be careful with what you call remove on. Touch means it create an empty file called file name. You can change the file name. Anything in this bracket can be changed based on the name you want to do. All right, so after we know the basic command, there's this thing called wildcard, right? So you can use store to refer to everything. So if I do ls-l store means that I want to list everything in this folder. You can use slash between each directory level. For example, /full/store refer to every single file and directory under /full. Typically, this wildcard character represent one or more characters. Store means 0 or more character. The question mark sign means a single character. Right? So something like /full/? It means that whatever file and directory in the folder called full that only have one character. A bracket means a range of character, right? So for example, what does this do? ls-l a*? This means that it's listing any, right, file and folder that start with the letter A, right? The letter A, followed by one or more character, right? So if it's just a store, it means that the file name A will count here. But if I do A*? It has to have at least one more character at the end, right? MVU6 in the bracket, question mark, star. What does this mean? It means that I want to move, well, the command will be broken because I didn't put in the destination, right? But U6 question mark star means the file and folder start with U has to have the number 6 afterward, followed by at least one more character. Over here, public slash underscore HTML slash star question mark G is something, a file from any files that has an extension, right? Dot, right? Dot is an extension. Something G, like JPG, PNG. Right? So if you think that all the image files would have the ending with a G, like IMG, PNG, JPG, you can basically move all of those in a single command to this one folder. All right. So now that we cover a lot of basic commands, you might have a question of how do I know what are the different arguments and options I can do in a command? The first thing is you can call a manual function. This is called man, or sometimes we call it a man page, right? So if you call man ls, it basically will print, right, the manual how to use ls. It would explain what ls is doing, what are the different options, what does ls-l mean, -a, what does it mean, -r, what does it mean, different dashes. I'm going to show you in a demo in the back, right? Cat, it means concatenate. It doesn't mean an animal. Basically, you concatenate multiple files into one. So over here, we have file 1, file 2, file 3, file 4, file n. It would basically stitch all these files together and then print the result. Print the result on your monitor. You might be wondering, if I just print the result, what's the use of that, right? So we'll cover that a little bit. Find, it means I want to find a file. So many typos in this slide. I want to use the command. I can use the command to find the files. PWD, print working directory. Basically, print the path of where you are. Print the path of where you are. Grep, this is one of the most common command that I type in my life, I think. Basically, it allows you to search for specific keyword in a specified list of files. So what I usually do, how many of you, when you program, you want to find wherever that variable is defined? A lot of time when you deal with big, like large piece of code, right? It can be 100 different files in one folder. And you want to find where did I define temp1, right? I can do grep temp1 star. It will basically search for the occurrence of temp1 on every single file. Yes, the presentation will be uploaded on Canvas. So now that we talk about this list of new commands, right? One of them is cat, which basically print the concatenation of all the files. We need to talk about redirection. What does redirection means? A lot of time when you run the command, right? UW cheat sheet. Oh, that's a great question as well. So first of all, the first question is, will the presentation be uploaded on Canvas? I think it's already there, but I'm gonna make sure it's there. Will there be a cheat sheet on your exam? Usually yes, but now that it's a online exam, probably. I mean, your cheat sheet is Google. I think it's the biggest cheat sheet you can have available. Because online exam, I can't do anything. I can't just say, hey, close book, right? I mean, how can I go to all your houses and control that? It's not physically possible. So yes, there'll be a cheat sheet called Google. When you're actually going through your assignment, you can ask questions. You can brainstorm with your friends, like, hey, type this command and it behaves this way. What's going on, right? You can ask Piclip, our TA, for that as well. He will be happy to go through these questions with you, right? And you can ask me for sure. So let's cover redirection, right? For example, a cat command, right? Say you have these three files, A, B, and C .text. You want to string them together, basically chain them together into one single file, right? But without the redirection, it will just print on your screen, right? It will just print on the screen. This symbol, the greater than sign symbol, means that whatever gets print on the output, don't print it, but print it to this new file you created over here, output.text. Basically, after you type this in, the content of A.text, B.text, C.text will get merged together. You create a file called output.text, and every content in A.text, B.text, C.text will be in the output.text. This is one of the most common things you use in Linux. Trust me, in the future. So if you don't want to create a new file, but you want to append, right? Put it at the end of existing files. You can do double greater than sign. It would append instead of adding new files. You can use the less than sign now to okay, that's a great question. I guess you can do. So the question is, can you use this to rename a file? We can try. So I think one thing we can do is to do cat, right? A.text into temp.text. It will be more like a copy file, right? Because you copy the content of A.text into temp.text, but you did not actually delete A.text. So that's I guess the answer is yes and no. You need to don't remember to remove it. It's easier to just do MV to move one file to another. That's like one command and that's it, right? So you can use this less than sign to redirect again, but now instead of redirecting some output to a file, you redirect the files as an input to a function or a program. For example, you have a text that lists a bunch of locations, right? And you want to do ls on all that locations. You can do ls less than file list.text. It would literally go through that list and perform ls on all of them, right? So redirection go both ways. Now that we talk about redirection, we need to talk about one last thing called pipe. What is a pipe? In real world, pipes connect one output into another input, right? It allows the flow of water from one place to another. That's what the pipe is. It's the same in computer science, I guess in Linux. A pipe means that I'm going to connect two commands together. The first command generates an output. The output goes through that pipe as an input to the next command. So you can use this vertical bar to forward an output of one command as an input to the next command, right? WC is word count. Anyone want to take a stab at what does this command do? Cat files pipe into word count. So this basically means that I'm gonna print the files, right? That's an output. The content of files will be fed as an input to word count. Basically, now you're counting the number of words in file. Think of it as you connecting the two functions together, right? You have command one, command two, and you use the pipe to connect the output into the input of the other command. All right. So I know it's a lot of things, right? So again, we'll do a demo at the end of this class. Before we go to the demo, there are more things we have to talk about. So let's do a mental shift into managing user and managing groups of users, right? So there are different user types: regular user, super user. Super user, as we discussed, God, they can do anything, right? Each user belongs to one or more groups: admin groups, pseudo group. What does pseudo mean? It means that I can elevate myself to become the god, right? So most of the time I'm human, but I can call pseudo to become a god, and then I can come back to become human. Pseudo means that I'm in the group that can always elevate myself to be a god. You can use the word group, followed by the username, right? So you can do group Rashada to check the group that the username Rashada is in, right? You can, as I said, if I call sudo for a people in a group sudo, they can become the super user. Each file and directory has an owner. Typically, these are whoever created the files. They own the files, right? These ownership can be changed using the command chown, change ownership. Each file also has a group associated with it. Usually by default, this is the group that the user that created the files is in. And each file and folder has 3 permissions. Right? You can read, you can write, and you can execute, run. You can read, write, and run. The reason why it's X is if you just do run, you can't use another letter R, right? Each set of permission, read, write, and execute, applies to ownership, group, and everyone else. So here's the example, right? Here's an example. If I do ls on a folder, right? So this is one of the folder with a bunch of student submissions, right, for the assignments. You see this folder name. And in Linux, this is directory, right? So directory and folder, they're the same thing. You see a bunch of names here, right? This is group that owns the folder. Everyone here, as you can see here, every folder that follow the MUIC student ID pattern is in the group student, right? And then you see here is the username of the owner. Okay, so the owner can also see the username. Not the owner can see the username. You can see the username of the owner of that folder, right? And you can see here, right, a bunch of string of letter. D specify this is the directory. You can go in there. It's not a file. R, WX, if they exist, is readable, writable, executable, right? RWX for the first set is for the user, for the owner. For that owner, they can read, write, and execute, as you can see here. Or the next set, RWX, right, is for the group. For example, here, you see that this folder called recycle is accessible by the root. They can read, write, and execute. The last set of letter is for everyone else. So in your submission, no one can actually see your friends read from it, right? Except for the case if you're in the student group. Now let's actually kind of like talk about super user and root, right? So super user is a terminology in operating systems that means it's the most privileged user. It's the all-powerful being inside a computer slash God, I guess. You can do anything when you have the super user. In Linux, this user is called root, right? Su, the command, right? Su change you, and you will become the super user. This means whenever you type su, typically Linux will ask for the root password. This is to protect everyone else who are using the computer, because if the virus come in and type su in the command, they would need to know the root password. This is also why when you're sharing things, build a machine, make sure you don't give everyone the root password. This is one of the really absurdly common mistakes that I see a lot of I would say server management company in Thailand. I'm not even sure why. If they're this bad, I'm not sure how they can run the company. Like I was about to say they're retarded, and I think it's the right word. I'm sorry, I'm typically direct person when it comes to things in my own expertise. And this is a bad situation. I've seen so many companies who are like giving the root privilege to a bunch of users. These days getting a lot better, but back in the day, like 10 years ago when I was a high school student, I was like, what? I didn't know over the time, but now that I think about it, it's like everything here is so dangerous. Like it's so easy to hack, so vulnerable, and I'm not sure how they even survive this long. I guess we are in the third world country that no one look at. And that, I guess, is the reality we're in, right? So it's better that you know these things, so that when you graduate, become an engineer, you know what's going on and you know what not to do. Please. Sudo is a command that elevates yourself to super user and run the command you put in. It allows you to run every command. So don't ever use root casually, right? I guess again, it's amazingly common thing in Thailand tech industry. They are all retarded. This is extremely dumb, and I just explained why. It is extremely dumb. Like don't like, for the 10th time today. It's bad. It's bad. And here's like a meme, I guess. XKCD. I'm sure you all seen XKCD one time, or at least one more time. At least one time in your life. So the meme is this: basically, there's one guy say, "Hey, make me a sandwich." The other one's like, "What the heck? Why do I have to make you a sandwich?" Right? So they can say, "Sudo, make me a sandwich," and the other person will have to follow your command. This is literally like king/god, right? Basically, you can command whatever. That's why you don't want to make everyone become sudo, especially in a shared server. In a shared server, you can change. So if you remember the earlier slide with different permission, RWX, right? And let's say you own the files, and you want to make sure everyone else can read, write, and execute the file you created, right? So you can change the permission of the files by using, basically you first need to be the owner of the file or the super user. Again, if you are the root, you can do a lot of things. You can set the bit mask that has a string number, right? RWX. You can use the word, not the cube, the command chmod. Chmod allows you to change the permission of each file you own, right? The number you put in, basically you can do chmod 777, so that 3 number, right? And then file name. The number you put in, the first one is for the owner. The second one is for the group. And the last one is for everyone else. What does 7 mean? Basically, 7 means the summation of the permission that you want to add them, basically to give, right? So if you have the number 1, executable. 2, write. 4, read. So if you want to give them read and write permission but not executable, you do 4 plus 2, which is 6. If you want to just give the read permission, you do 4, right? Plus 0, because you don't want to give them execute or write permission. If you want to give them read, not write, but execute, this is 4 plus 1, right, which is 5. You can use chmod 5, will give you the read and execute permission, but not write. So you can overwrite the files. If you want to just do execute and write, but cannot read, which is kind of weird, right? You can't read the files, but you can write to it. You can do 2 plus 1 equal 3. This is not a common permission. A common one would be read and execute. Wait, you can list the files that know the file exists and then execute on it. Read, write, and execute. Also read and write. If the files should not be executed, just put RW. Don't run the files because it means nothing. For example, chmod 777 test.txt, this allows every single user to read, write, and execute. chmod 744 test.txt allows you as an owner to do whatever. The group can read from it. Everyone else can read from it. 742 means the group can read from it. Everyone else can write to it but cannot read from it, which is kind of weird again, right? But these are just examples. So question time. I say everything is a file in Linux, right? So it means that every program that you run is a file, because everything is a file, including the program. When you want to run a program, you call the files. This means that, well, first of all, everything is under root, right? Every single program will be under root because the file structure starts with the root, right? So when you run something like ls, for example, if the file called ls inside the folder you're in, because you need to provide the path, right? To access the program, you need to provide the full path. You need to know where it is, right? So my question is, how does Linux know where ls is? So this is a rhetorical question, right? Oh, okay. That was a comment, which is another awesome comment. Sorry, I did not check a chat earlier. So root as an internet username for every newly installed internet. Good. I guess that can confuse a lot of people, but don't do it, please. Yeah. So yeah, folks, be nice to everyone else. I mean, the internet community, even though it's virtual, I mean, there are human behind it, right? Well, except bots, but so we do have feeling. Don't destroy other people's things or confuse people. So let's go back to our question. Somehow, right, there has to be a mechanism. There has to be a mechanism for Linux to know where exactly the file for that command is. ls is not a command that appears out of thin air. It's a program. It's a program that's located somewhere. Right? This is done through this special variable called path. What is a path variable? The path variable basically allows the shell, right? What is shell? Shell gives the command to the OS. It allows the shell to know some pre-configured value. These pre-configured values are called environment variables. A path variable is one of these variables. It contains a lot of directories separated with colon, right? ls in reality is stored under /bin/ls. When you go to /bin, these are where all the common Linux commands are installed, right? Whenever you install a new command, it's there. So one common thing that you would do is to put this directory inside the path variable. So in this case, it means that somehow this path variable contains /bin, because it would basically go and search that folder for that command, right? So to check the actual location of the command, you can use the word which ls will print out the path to ls, which cd will print the path to cd, which chmod will print the path to the command chmod. And you can modify the path variable using these series of text, right? When you use the $ in front of anything, it means that I'm gonna print the value of that thing, treat that thing as a variable and print the value. Then you can use the export keyword, right, to modify the content of that variable. Path is a variable. So what I can do over here, if I want to add a new directory in my path variable, I can do this. What does $path do? It prints the current content of path, right? It prints whatever path is right now. So it can be /bin, /bin, some other folder. I use the colon here, so I'm going to erase this a little. So here, followed by colon. Colon means that I'm going to add one more directory, and I type the directory I want to add in, right? This means I'm going to add /home /rashada/bin to my path variable. For example, so there's a command called echo. Echo basically print whatever you want to print. So if you do echo $path, it will basically print the content of the path variable. So over here, right, over here, if I do echo $path and I got this, it means that inside the path variable, there are 3 folders, /user/bin. These are the program installed by different users. /bin is the program installed by typically by Linux. It's like a default command. /user/sbin is another common folder where programs are installed. Right? So as I said, there's an echo command, basically print what comes next. Echo hi will literally print hi. Echo $path will print the value of the path variable. All right. So it's been quite a while. So before we switch up to talking about processes, right? So let's take a quick break. So let's meet again at 1:20, like 6 to 7 minutes break. All right. So we'll meet again at 1:20, and we'll continue to talk about processes. If we don't have enough time for the demo, I would like to switch to Discord first to troubleshoot every single issue that we have with VM installation and proper discussion, and then we'll do the demo on next week. We'll do recap and demo. This way we have enough time dedicated for how to use Linux. For now, let's take a break and get coffee. It's a lot of content to chew on. I'll double check if my slides is already on Canvas, but I think I published it. So if you cannot find it, but somehow you check Canvas again and you found it, let me know, please, on the chat. Otherwise, we'll meet in 5 minutes. All right. All right. We are back. Okay, cool. So let's continue on a little bit and then talk about the task manager version of Linux to make sure you can control whenever program hangs or crash or bad thing happens, right? So let's talk more about processes. Process, as I said, these are the running instance of the program, right? So it runs under certain corresponding environment. For example, the path variable is one of the environment that these program will see, right? So these environment provide additional information required for the program to run correctly. Each of the process has unique things called process ID. The process ID, think of it as if you are like a citizen in Thailand, right? You have the citizen ID. That's the process ID. Everyone has a unique number. The parent, it also have the parent unique process ID. Basically, it will tell who launched the process. So you can basically trace, right, the source of who created that job. Somehow when you have virus, you need to trace the parent and then try to see who ran it, right? It will also have a unique user and group. Sorry, that was like my cat fur in front of the.
Ajahn, is the parent process ID like the Chrome app and its tab?
Yes, actually. So you open a bunch of tabs, right? Each tab you have the process ID. In all likelihood, the engine that kind of like behind Chrome app will have that launch, basically the one that launched the tab will have the parent. It will have the parent process ID pointing, right? Pointing to that parent process. Let's say a tab open YouTube and YouTube requires another thread, basically another process to deal with the MPEG video and showing the video to your screen. Then the tab will be the parent of that YouTube like built-in process. Each process also has user and group number who owns the process and what group owns the process, because sometimes fishy thing happens in your computer. A lot of fishy thing can happen on your computer. So this information is useful for the admin. Another thing that's in there is a priority, right? So what is a priority? It basically tells how important the process is. One example is if you're printing something, right? If you're printing some documents, do you care about whether it gets printed in 1 second or 1.5 seconds? Not really, right? So it typically will have lower priority. But let's say you are playing games and you're about to shoot someone in the head, right? And you're trying to win the game. That process is likely more important to you than sending a command to print the assignments on your printer. You probably care about whether you can shoot someone in games rather than printing your assignments, right? So the OS would actually assign priorities based on what is it based on? It typically based on the nature of the job, right? So these scheduling and controlling on who get to go first and things like this is actually more like an OS topic, operating system topic. And these have to be designed and basically it has to be actually carefully designed in many systems. For example, in a self-driving car, you want to make sure you handle this priority properly. Right? The management of the process, you can use the word top. This is a command that print real-time data about every running processes. As I said last class, right? When you type in top, this is like task manager in Windows. By the way, do you hear like my cat bell ringing? Because it's literally sitting right here in front of me behind the laptop. And if it's annoying, please do let me know. So yes, you wake up. So you can think of top as the task manager in Windows. PS is a command to list all the running processes. Kill is a command that ends the specified running processes. Jobs list current job that runs in the background. Basically, whatever you're running, there are two things: foreground processes and background processes. What does foreground mean? It's the front thing, right? Background means it's whatever is in the back. So in most cases, when you're in a terminal, the command you're running right now is a foreground job. The rest, there are a lot of process, trust me, that are running to make sure the computer function properly, right? To make sure everything function properly, the display driver has to show the correct thing. The audio driver has to basically play the audio. It should have the microphone driver that can detect like my voice right now. The webcam driver that can detect my face as well as some part of my cat's hair that you see around. So everything is actually running in the background to make sure everything works properly. Last class, when you told me my microphone went haywire, that was when the driver was acting weird, right? So what I did was disable the mic and somehow enable it again, and it works. Jobs, kill, PS, all these commands are there for you to control what's running. Jobs will just list what's in the background. PS, all running processes. FG, foreground job, right? It would print basically. FG process ID basically move that process from background to foreground. Control C, because if once it's a foreground process, you can't type in the new command until the foreground process finish, right? So to pause the foreground process and move it to the background, you Control C. Control C is basically switch that whatever you're running to the background process. And here's some example using PS, right? So if you type in this is one of the really common usage, PS AUX. What does A mean? A show all the process from all the users. U display the user or owners of that processes. X shows basically show the process not attached to that terminal that you're typing. Basically, background processes that are running. So if you type in PSAUX, this is what you get. It will show that right now 5 root processes running, right? A bunch of system and network processes, right? The command that is associated with the process, right? Process ID, init, right? This is when the computer boot up. Process ID 1, the first process. Then you have ongoing different process IDs you can see here. CPU usage and memory usage. Basically, it tells you when at that instance, when you type in the command how much CPU and memory they're using. Most of the time, these things are sleep. They're not really using the CPU. You can look at the start time and how long has this thing been running, right? So to actually terminate the process, you can kill them, right? It's actually send a signal we call sig kill, right? Sig kill will actually kill the process. If you are in the OS class, these signal, there are a bunch of signals that you can send to a process. Sig kill will terminate it. Example is, let's say I type in kill 1, 2, 3, 4, 5. This basically kill the process with the process ID 1, 2, 3, 4, 5. This is useful to terminate things like buggy programs or zombie processes. What are zombie processes? What are zombies? It's like human that turns into something without the brain, right? And do weird things. And you typically want to kill zombies. So in your computer, zombie processes are processes that's supposed to die. It's supposed to get killed, but somehow it's there. it becomes a zombie. Occasionally, what the OS would do is to try to detect this and kill it. Yes? Sorry, is that a question? So let me check the chat question. Basically, is it like a Chrome after we close the normal windows, or is that you mean the kill command, right? Yes. Basically, when you close a window, zombie processes. Oh, yeah. So if you look at your task manager, typically you see a bunch of Chrome, right? Yeah, those can be zombie process. Depending on what get open, sometimes this Chrome process sneakily run in the background, even though you're not actually open it, or if you close it earlier. There are some benefits to that. For example, what are the common things you do in Chrome? Go to YouTube and watch a video, right? So a lot of time these processes, when you open up Chrome, right, it would try to maintain some of these like helper, I guess, programs that are common for the user to make sure everything is fast. So depending on the situation, sometimes it's actual zombie, sometimes it's a legit processes. So in the case of Ubuntu, if you know it's a zombie processes that you're supposed to kill it already, you can try to send sick kill. It would actually kill that zombie process. What are other useful commands? wget is downloading the files from the internet. So you could put in the path to that files. Wget with the path, download the files. Zip and unzip, self-explanatory, zip and unzip. Tar, I'm not sure if you heard about the word tarball in computer. Basically, tar means I'm gonna pack everything, a lot of files, into one single file. The difference between tar and zip is tar doesn't actually compress. Zip, you compress them. You make it smaller. Curl is a HTTP client. Basically, it allows you to access the internet from your terminal. Things are getting more fancy. Head, when you type in head file name, it print the first n lines. Tail, similar to head, but print the last n lines. So with these commands, there's some useful tricks that I want to tell you, right? The up and down arrow on your keyboard will cycle through the previous and next command you've been using. So if you want to go back to the 3 commands ago, you can go up. It will go back to the last 3 commands that you type in. The tab is autocomplete if you're lazy. This whole module is about being lazy, right? So I can type in the tab to autocomplete things like folder names if it's possible. Control C Charlie, not C as in zebra. Control C will stop the current program. It's not moving it to the background. It stops the current program. Control R will allow you to search the command history, all the commands that you've been using in that terminal. Control L will clear your screen in case you don't want people to see what you've been doing. Control L, gone. Dealing with multiple names. So this is aliasing. Introduction to like dealing with different names. So what if you have executable called ls under the working directory and you want to run this one instead of the command ls? You need to specify the path. Otherwise, when you type in ls, it goes to the /bin/ls, right? So let's say you have ls in /bin/ls and /home/brush/ls, right? If you want to run this particular version of ls, just type in ls. If you want to run this version of ls, you need to actually type in either // which basically go to the current directory, right? Assuming that we are in the home directory and then // ls, or actually put in the absolute path. /home/rashada/ls. Why is this important? How many of you use Python 2 and 3 at the same time? So if you use Python to program, you might have noticed that Python 2 and Python 3, different libraries, different tools would like to use Python 2. Different set of tools prefer Python 3. I'm sure throughout your career at Mahidol University student, you'll run into some cases where your tools demand Python 2 and the other class would like to use Python 3. What you can do is install Python both version on your computer. When you type in Python, it will likely go to one of the version, right? If you want to use the other version, make sure you put in the path to go to that correct version of Python. All right, so let's talk about executable. I think we're almost done with the current lecture. So using the shell, you can run things, basically any valid binary file that contains instruction that the machine knows. If you go into like computer architecture, and if you stay until module 3, we'll talk about what about files that are executable. What does it mean, right? So you can run a valid program, you can run a script. What is a script? Things like Bash and Python, right? The shell script. You are going to do this for your assignments. You can specify the type of the script that you want to run. If it's a Python script, you can use the shebang. Shebang is the $sign and exclamation mark. Not sure why it calls shebang. Maybe I should look it up so that I can tell you. But exclamation mark would tell use this command to run the script. So if you do shebang user bin Python, it means the script is in Python, use Python to run it. /bin/bash, this is shell script. So just run it as if it's a shell command. You need to make sure that files also have the executable flag, right? The chmod with the X. You can add the executable flag by saying chmod plus X plus mean I'm adding, X mean executable. I want to make sure that file is executable. So let's talk about shell. Actually, let's talk about shell scripting later. So let's wrap up this class. We'll talk about shell scripting in the next class. Let me double check how long. Yeah. So let's talk about shell scripting in the next class. Otherwise, it's going to be way too long, right? Let me show you some demo. So as I said earlier, right, you can use PuTTY to connect to this server. Do you see my screen here with PuTTY?
Yes, Sachin.
Okay. So what I have set up here is actually save a session. Basically, normally I had to put in the IP address. Actually, I saved the IP address on this shortcut here to connect to the MUIC server. What you have to do is first you need to connect to the VPN, the Mahidol University VPN. Because I'm a part-time lecturer, I actually don't have the VPN account. Thank you, Johnson, sir. He built in a side channel for me to log in. So I basically can first connect to this machine, which opened up to outside world. So I would first open this, but let me make sure I have set the font size to be big enough. All right, and we go to session and connect. So I'll connect to here, system skill outside. Still not big. I'm sure no one can see what is the text. So I'm gonna change the appearance again to make sure this is easier to see for all of you. Font, I would say 24. All right. Okay. Bye. Is it big enough? Can you see the login as?
Yeah.
Okay, perfect. So I'm on one of the machine, right? And let me move my cat so that I can see the screen. Oh my God, this is not safe. Yeah. All right, so this machine, the outside machine is called Genesis. It's not sysq. If you want to go to sysq, I would have to actually put in this thing, this IP 10.126.125.13. So once you connect to the VPN, you can use the same IP address to connect to system skill. I actually make this a command. So I can do .go sysq. Basically, I'm running this command. The command will connect me to that machine, right? And it would first ask me for the password. I put in the password and it should connect. Basically, now when you connect to the server, this is the first thing you see, some welcome message, which I never read, to be honest. All right, so we talk about LS, right? Right now, when I log in, as I said earlier in class, where is that directory? I'm in my home directory. So if I do pwd, it should print /home/rashada, right? pwd is print working directory. If I want to figure out what's pwd, man pwd, it actually tell me what does pwd do, plus some options that you can add. All right. If you want to exit the man page, type in Q, the letter Q. This letter Q will exit the manual. If you type in ls, as you can see, there will be a lot of system skill term 3 earlier term submission from your colleagues, right? So I can go to one of those. So I just hit tab. See, I hit tab, it autofill. Because there are multiple versions of the sysq folder, it stopped at dash, right? Because there are 2020 version, and there's a tester version that I built in, right? So if I go there, you can see, right? There's some of the assignment related files, and this is safe, so I can show you this is not like the solution or anything. I can do cat test.csv. It prints what's in the test.csv, right? What are the other commands that would print the content? Head, right? Same thing here. You see the same thing. It prints the first 10 lines of that file. Because this file only has 3 lines, it prints everything. So ls again, right? So if I want to go up one directory, go back, right? I can do cd ... and go back to the home folder. If I want to go to the root directory, I can do c/. It will go to the root folder. How can I tell? pwd, right? You see that I'm in the root folder, in the topmost folder. What's in there? It's a bunch of system-related folder, including the home directory. You can see the folder called hand in and hand out, right? These are important for you. The handout folder is where I put in the handout for the assignments. Right now is the old semester, right? So you can go to A3. You can go to, well, you see one file called handout.tar.gzip. It's a compressed version of the handout files. If you uncompress it, it's in here. You see that there is a bunch of C files. So you can do head test.c. Oops. Oh, test with the letter S, right? It prints the first 10 lines. If I want to print more, I will first have to check the man page for head, right? And it can print number of bytes, number of lines, and you can see that -n will print the first num line. So let's say I want to print 25 lines. I can do head -n, right? -n specify number of lines you want to print, and then test. Let's see. Now you will see that I print more lines, right? If you want to modify this file, you can do nano. As I said, it's a text editor. You can go in there and type whatever you want, right? Type whatever you want. To exit, you do Control X. It will save. It will ask me whether I want to save or not. I say no because I don't want to overwrite the old files, right? What else? So I can go back to home again, right? I can go to, let's do, this is a script again, right? That what I do here is just print, right? Print the content of item.text, right? So I just Vim is another text editor. And here's item.text, right? Test script here. So if I run test.sh, it would just print I because there's a bug in there. Oh yeah, it's just echo I. So if you want to fix this, I just need to do $i. Test script here, right? $sign is a variable in there. The script is $I, means I want to print whatever is in I. What is I? It's a cat of that file. We'll go to scripting next lecture. Right? Basically, it's chaining a lot of commands together. You can, what else can you do? Redirection, right? Redirection. So word count item.text is counting number of words, right? If I want to count number of words for both taste.c and item.text, so look at these two output, right? What I can do this, cat item.text test.c. So I want to do both files, type into word count, see that there's a sum, 18 words, 15 plus 5, 25, 22 plus 3, 139 is, 156 is 139 plus 17. Number of lines, number of word per line, but no, something. I forgot what the middle number is. And then the number of words at the end. Wait. Number of lines, number of words, number of character. So you add number of lines, it's equal. Number of words, it's equal. Number of characters also equal. You can type like this. Not type, redirect as an output, right? Temp, so many temp right now. Skill test temp, right? If I go there, nano, I'll just use nano for now so that you are more familiar with it. You will see that I basically do test script here followed by another program. These are C code, right? So you're gonna get really familiar with this. This is a really simple code that just add two numbers together. And you can see here, I just append the two files together. And exit. And that's pretty much it. So if you want to use top, it would look like this. I just type in top. It shows me what are the running processes right now, right? What are the different user that's been running this thing? And I can exit. So if I'm going to go out of top, I could do Control C, go back to the normal program. All right, so, and now my cat is like sleeping right here. Finally. And what else did we cover? I'm not gonna queue any process here. Everything is important. But I guess we can do PSAUX, right? Again, it would print running process by other users that you can kill. Hopefully, in this case, everything here looks legit. So I'm not gonna queue anything here. Any questions before we basically adjourn for today? Or anything you want me to try that doesn't involve removing a lot of things? So I can do mkdir, JS folder. All right, and then I can touch file with a spacebar in between. One. You see that there's a spacebar in the middle of the file name, right? So to access it, I need to put in the slash, and then white space. It's an escape character. I can modify this, right? Get exit, and then if I vim it again, you'll see the changes. So these are text editor. All right. So with the demo, you see in class exercise 2, actually, I do not recommend it right now because actually we haven't finished the whole material that we want to cover here. So let's do this next Tuesday. All right. Any questions so far? Now that we do some demo on the real server.
So we have only like one homework at the moment, right? To install the text editor, right?
The text editor, make sure you can modify the C code files. Once this weekend is over, you will have access to the server.
Okay. So that's the only homework we have right now.
Yes.
So assignment 2 will be next week.
So these are in class exercise. These are not assignments. So let me be clear. There are two things. In class exercise that I want everyone to do. They count for the total 10% in total for your grade. The assignments are different. The assignments will be out next week. And the first one will ask you to do Linux scripting. The reason it's not out yet because we haven't covered that. It's literally our next topic, right? So once we cover that, you are basically ready to work on your assignment. All right, so let me exit. Okay. So I just exit that terminal, right? I just close the terminal down. The program, everything in the server is still running normally. I just disconnect from it, and now I'm back and on my PowerPoint slide. And next Tuesday, we're gonna cover how to be even lazier. Because you can write series of command in the files and don't have to repeat the same thing again and again and again and again. So we have roughly like 3 or 4 minutes left before I need to join another session of the same class. Any last minute burning questions? Otherwise, I'm gonna go to Discord. Otherwise, I'm gonna periodically check this for an email. I'm sorry for those folks who email me since Tuesday evening. I have a book chapter that I have to finish by Friday that I did not know. I guess not completely aware of the deadline. So